exercise chapter 3, 3.4. We solved this problem, and the problem is we have a partial p by partial t plus, and when we multiply this A matrix with this derivative, then we get some equations. But this is not our problem. In fact, the problem is that we have a coefficient matrix A and we have initial condition given over here. The initial condition for pressure, this is for pressure. Initial condition only exists from when we have 1 to 2, then the initial condition is 1. Otherwise, it is 0. Here it is 0 and it is 0 over here. And the initial condition for U naught is also 0. It is similar to the previous chapter where we had some equation written like this: A partial Q by partial X is equal to 0. And sometime we want to write the system of equation in the matrix form. This is written, the equation is written in the matrix form. Our aim is to find the solution for t is greater than 0, so on. So first of all, we write the system of equation as like this: partial q by partial t plus a partial q by partial x is equal to 0. Here q is a column vector. Usually it is bold over here, so bold mean it is a column vector, and the column vector is defined like this. So when we have a system, we can write it like this, given in equation 1 and 2. So that's how the problem, the given problem, is written in the system of equations. Sometime it happens that you write equation 1 and 2 in the matrix form. For example, we have partial p by partial t plus k naught partial u by partial x equal to 0, and partial u by partial t plus 1 over rho naught partial p by partial x is equal to 0. So you write this as a in the form of partial q by partial t plus partial q by partial x is equal to 0. So it is both ways. When we have a system of equation, but then we can write equation system of equation in compact form, and similar to that, when we have a compact form, we can write it as expanded form. Okay, initial condition we already discussed, it is given over here. Now the only thing is we need to find the eigenvalues and eigenvectors. Every system is solved with eigenvalues and eigenvectors, eigenvalues and eigenvectors. Okay, so in chapter 2 we also solved the same system with eigenvalues and eigenvectors. So your aim is to find the eigenvalues from linear algebra. So you should revise the linear algebra concept, how to find the eigenvalues and eigenvectors. If you get time, you can do that. So we get the eigenvalues, two eigenvalues. One is with lambda 1 is equal to c naught, and another one is lambda 2 minus c naught, where c naught is k naught over rho naught. Sometime it is written like this: p dash under root rho naught. Okay, it is the same formula. So from here we can get this is just an exercise. You can find the eigenvectors yourself. So the general solution of such problem is f of x minus c naught t plus g of x plus c naught t. That we already decided in the theory that whenever there are two equations, the solution is written in terms of the two waves. And you also remember that when we had two equations, we can write those equations in terms of single second order equation. And from PDE, we know that it has two solutions. One is going towards left and another is going towards right. Okay. So P of xt is written like this. So after that, what we do, we actually, there are two solutions. One is for pressure and another one is for U. The pressure, the solution for pressure is written f of x minus c naught t and gx plus c naught t, and the same goes to for the pressure for U. Otherwise, we could have only one solution. Okay. Then what we need to find, we need to find the f and g from here. Okay. This is one of the ways to find the solution. At t is equal to 0, we have p naught, and when t is equal to 0, we have 0. We need to find the function, unknown function f of x and g of x. Then we solve this problem. F of x is 1 by 2 p naught x, and g of x is also 1 over 2 p naught x. Okay. So our solution is 1 by 2 p naught x minus c naught t and 1 over 2 p naught x plus c naught t. Since we remember that your initial condition always moves towards the left or towards the right. So this is our final solution. Okay. So this was exercise 3.4. Here you remember you have to write your solution as alpha 1 and V1 plus alpha 2 V2. Then you get two solutions, for one for pressure and one for velocity U. You just need to find out the alpha 1 and alpha 2. Then you get this solution and another solution. Thank you for watching.